Hello, everybody, and welcome to the Reuse Company webinars. Today, we're going to talk about digital verification and validation according to ISO 15288. Today's presenter is Jose Pereira from the Sales and Consulting Department, and my name is Cecilia Karlsson, and I will be the host today. Jose Pereira is INCOSE ACEP certified, and he is a major contributor to the INCOSE Guide to Writing Requirements. Jose is a sales and consulting representative under CSEP and ECEP certified colleagues. So what do? The Reuse Company is a tool vendor specialized in the application of semantic technologies and artificial intelligence to improve the digitalization of the systems engineering life cycle. So let's start with today's topic. Hello, Jose.
Hello, everybody. Can you guys see me?
Yes.
Perfect. Okay. So first of all, let me just change the perspective here. I think the presentation is giving me a few issues. Let me just try it. Okay. Excellent. So thank you very much for the introduction, Cecilia. As you have mentioned, the session or the purpose of today's session is going to be revising verification and validation, which is a topic I've been involved around, let's say, 3 to 4 years now. And this topic is quite a passion for mine. And basically what this session will consist in is basically an introduction into verification and validation. And then we will go on to the processes that comprise verification and validation in the INCOSE, let's say the handbook, right? The ISO 15288. And we will revise all these different processes and how we can actually apply them on top of the SES Engineering Studio. So with that out of the way, let's begin with the chapter 0, which is going to be introduction to verification and validation. So as I mentioned, this is going to be the ISO 15288, and this is gathered under the Systems Engineering Handbook from INCOSE. Within this handbook, we have many different processes, right? And we will today focus on 2 of the technical processes, which are going to be verification and validation, which, if you recall the V model, right? We will take a look at it later, but the V model on the right-hand side is going to have, let's say, the system, and on the left-hand side is going to have the requirements model, so on and so forth. This is a very high-level way to put it. We will get into more detail later, but the verification and the validation take place all across the V model. Okay, so both in the left-hand side and in the right-hand side. So one of the first things that we see when we go into the verification and validation chapter, by the way, you will see that in the slides, you can appreciate, let's say, the topic specifically talking about validation or specifically talking about verification. But for the sake of this presentation, both are going to be treated equally, right? Within the tool, you will have access to both verification and validation equally. So please feel free to just, if you work with verification instead of validation, apply the exact same processes or ideas that I'm going to mention right here, even though the 2 processes are different, and I will get into more detail on which are the specifics on the differences, let's say, between verification and validation. Okay, but for the sake of the presentation, I'm going to focus on the IPO in the inputs, processes, and outputs, and specifically the activities here, the processes are going to be prepare for validation, perform validation, and then manage the results of the validation itself. Okay. This is going to be very important. We'll get into more information later, as it is going to be basically the structure of the presentation. So we're going to see how to perform all these different processes. We're not going to get into too much detail regarding the inputs or the outputs, but mainly the processes themselves. Okay. So this is the V model, as we have mentioned before. This is a little drawing that I prepared. And in this, let's say, schema, as you can see here, the V model itself. By the shape, it is pretty clear. And on the left-hand side, I want you to focus on the first item, which is going to be the blueprint of the entire aircraft. So in this use case, in this particular example, we're dealing with the creation or the development of a complete aircraft. And systems engineering, let's say the V model specifically in this case, is going to focus on two main processes. These two main processes are going to be, first of all, the system decomposition, right? Which is going to be basically taking the entire overall system itself, right? And decomposing in terms of complexity. So making smaller and smaller parts until we can reach the very bottom of the barrel and we can just tackle the smallest element or the smallest component that we can face, right? And then let's say go back integrating. But for the sake of this example, let me just put the laser here. This is going to be, as I was mentioning before, the blueprint for the entire system. In this section, right, we're going to take on the models, the requirements, let's say the needs for the entire aircraft, right? The next step is going to be going down onto the next part. Let me just go back, which is going to be the wing subsystem, for instance, right? So we're going to take the many subsystems. In this case, we're going to, let's say, highlight the wings one, and we're going to tackle the exact same processes that we have mentioned before for the entire system. So the models, the system requirements, needs, so on and so forth, right? We jump onto the next step of decomposition in terms of complexity, and we do the exact same for the engine here, right? Once we reach the bottom and we have elaborated or created, let's say, all the different system requirements, subsystem requirements, the needs, the models, so on and so forth on the left-hand side, we reach the very bottom and we start the next process, which is going to be the system integration, right? So now what we are going to do is basically take on all the guidelines that we have prepared on the left-hand side and use them to integrate the system, let's say, into reality, right? So let me just go a little bit back. And what we're going to do is basically from these smallest pieces, we're going to start by building those or purchasing those. Then we're going to integrate those into the engine. The engine is going to be integrated with other components into the wing subsystem. And this wing subsystem is going to be integrated in the end into the final aircraft itself, right? So we have the two main processes, system decomposition on the left-hand side and system integration on the right-hand side. Something that we can see and appreciate in the middle, right, and on the left-hand side are these arrows, the green ones, which correspond to verification, and the purple ones, which correspond to the validation, okay? So as you can see, we can highlight two main processes for verification, right? The first process for verification in terms of the timeline are going to be the verification of the system requirements, the needs. Well, needs are usually a little bit more complicated to verify, but we focus mainly, let's say for the sake of the example, on the system requirements, the models, so on and so forth, okay? This verification is going to take place between these system requirements, models, so on and so forth, against the organizational guidelines, quality standards, etc. Okay, so we're making sure that basically these requirements and these models are built, let's say, properly or accordingly. Okay, the second type of verification is the most common one, or the one that we speak about the most, right? I've heard even people mention or speaking about requirements verification in this sense. But this verification is basically between the system, so we're verifying the system, the physical element itself, against the system requirements, against the models, so on and so forth, okay? For the validation, we have the same, let's say, structure in the sense that we have validation either on the left-hand side and on the right-hand side. And we always validate against the needs of the upper layer, okay? So this is a little bit more straightforward. It is complicated to execute, of course, but the process is, let's say, the process itself, it consists on these steps, let's say, in high, let's say, in high terms or in high abstraction, okay? So, as I mentioned before, you can notice here that both verification and validation are applied throughout the entire V model, okay? Great. So now verification versus validation. Where is the difference? Okay. So we go into INCOSE, and the definition is going to be this one. The verification process is basically providing objective evidence that a system or system element, right? In this case, I would substitute this by any system engineering item or in any engineering item itself, that it is fulfilling the specified requirements and characteristics, right? So this not only implies that the system or the physical component is built according to the specified requirements and characteristics, but also the requirements themselves and also the models themselves, for instance. Okay. So the purpose is going to be providing evidence that there's no error, default, or defect, or fault. Okay. Then the validation is once again objective evidence, but in this case, instead of focusing on the characteristics and the specific requirements, right, we're focusing on whether or not it fulfills the business mission, or mission objectives, right? So basically the purpose that it was designed to satisfy, right? So here we have the stakeholder requirements. Against these stakeholder requirements, we're going to perform validation. And against the system requirements, we're going to perform verification, right? I like to simple things down, right? And to simplify things in very easy terms. So for me, validation is always building the right thing, right? So in this case, I could build the most wonderful boat, the perfect, let's say, way to travel by sea, right, or by ocean. But my customer required, let's say, a way to, let's say, fly or to go above mountains, right? My system is wonderful, it's greatly built, but it is not fulfilling the purpose that it was designed initially to, right? And on the right-hand side, we have the verification, which is building the thing right? This is what I was mentioning before. In this case, you can have, let's say, you can build an actual aircraft, but the aircraft is not properly, let's say, designed or properly developed, right? So in this case, the verification would not pass, okay? While the validation would. Both of them, verification and validation, have different context, different scope, and many other different, let's say, characteristics, but both share one thing, let's say, or two things: the methods and the tools you can apply, let's say, to perform these operations. Right? In this case, we have to highlight three main VMV core activities. These are the processes that we were mentioning before. So we have preparation, we have the execution, and finally we have the management of the results of the process of VMV. Okay, I'll not get into too much detail because we're going to go through all of these different steps in the subsequent slides. So we're going to go on to preparing for our verification process. In this case, as I mentioned before, when I speak of verification, this can also be applied to validation with the proper, let's say, adjustments. But the first step is going to be accessing the items to be verified. So you can see here for the first time the SES Engineering Studio, right? And in this SES Engineering Studio, we have these different pills or these different connections, right? So the SES is going to be basically an orchestrator, a place where you can connect to all these different tools and bring into this environment all the engineering items that you need, and basically applying technical management and many other capabilities on top of it, right? So in this case, we're discussing specifically about the VMV, and we're going to connect to one particular connection. In this case, I believe we have, let's say, PVS within an Excel file. The next step is going to be defining the verification action for each or for many different verifiable items, right? Let me define you what is a verification action. This is also part of the INCOSE handbook. And basically, a verification action is a place, in our case, let's say in our interpretation, it is a digital place, of course, where you can allocate all the information regarding the verification or validation process that you're later committing to perform, let's say, right? And it is very important because it allocates two types of information. First, the information which we are currently in the current phase preparing for, let's say, all the information prior to the execution of the verification. So what do I expect from the process? Which are the objectives that I want the process to fulfill? Which are going to be the elements involved in this verification or validation process, right? All of this, the allocation of resources, so on and so forth. And then another type of information which is going to be allocated in these verification actions is the actual results obtained, for instance, the verification or validation evidences, right? Along with which are the actual resources that you have spent, if there have been delays, which is the current state of the process, so on and so forth, okay? So verification and validation actions are fundamental. One of the things that I will, let's say, dive a little bit into is the methods and the techniques, which is what we mentioned before, that both verification and validation can share, right? Some of them are more suitable for one process and some of them are better for other, but in general, you could, let's say, put them together. And in this case, this is what we do, right? So you put all the techniques together and all the methods together, okay? Just in case the user wants to apply, any of them, okay? The first one for the methods is going to be the comparison rule. This is pretty straightforward. This is comparing two numbers. So we have here the expected numeric result. So we expect a certain value for the system to fulfill. Then we define the comparison rule, whether it is more or less than, so on and so forth. And then which is going to be the actual obtained result, okay? So, well, finally, of course, the tolerance as well. So for the next one, this is going to be the checklist. In this case, for instance, I find this more suitable for validation processes, right? And this is pretty straightforward. You can configure a set of questions for the users or for the validation agents to later fill in individually or collectively, right, for the validation process or the verification process. And finally, the most powerful one, also it is the one that, of course, takes more tailoring because it must be, let's say, custom made for each particular scenario. And it requires coding, in this case, so C# coding. And this is something that, of course, it is pretty powerful as you can adjust and tailor specifically to your particular use case, but it requires a little bit more of effort. Great. So for the preparation, it is also due to mention the fact that we are, let's say, mentioning or specifying which are the resources that we want to allocate to each particular, let's say, verification process in this case, okay? And the final thing that we're going to do is specifying the verification technique, right? So in the left-hand side, we have this drop-down menu. And as you can see here, we have different verification techniques. So inspection, testing, analogy, so on and so forth, okay? Great, so let's jump into a brief video. So we're within the SCS Engineering Studio, as you can see. Let me just, okay. And we have here the connection to our product breakdown structure. So as you can see, we have here the entire list of elements, components, subsystems, and the system itself that we have involved in our project. We're going to access the VMV view, right? So as I mentioned before, this is a hub where you can actually connect to different sources and bring all your engineering items and apply, let's say, certain technical management and other processes on top. So in this case, we're going to select the VMV tab, and we're going to select the option of performing or creating a verification template, right? These templates are optional to create. I like to create them because in many cases, let's say the process that I'm trying to execute, the verification process itself, let me just stop it here. The verification process that we're trying to execute might be common, or at least the overall structure of the process might be common in several different items. And creating a template instead of directly creating the action on top of each engineering item allows me to basically be capable of assigning this template to the entire specification or to a subset within the specification or the product breakdown structure for the sake of this example. and simply just tailor on top of it, right? So I can assign the template and then make the specifics, let's say, define the specifics for each particular component, subsystem, so on and so forth. Okay, great. So what we have done up to this point, let me catch you up, is basically pretty straightforward because we have filled in the name, right? And we have provided a rationale with information of the process, okay? In this case, now we have jumped onto the verification part. And in the verification part, as we were mentioning before, one of the first things that you do is select the technique for verification in this case. Okay, as you can see here, we have plenty of different options. In this case, we're going to select the testing one. For the method, the one that I did not explain previously, if you noticed, is the manual one. And the manual one is pretty straightforward, or is the most straightforward, because it does not change or alter the structure of the verification action, as it is simply a way of saying for the, let's say, verification agent or the validation agent to simply say, by my authority or by what I've observed, I attach here, for instance, a video, a document, an image, right? Argumenting that this verification or validation process is passed or is not passed, right? So it's pretty straightforward. It does not involve any comparison of numbers, any set of questions, and neither any custom code, right? So the manual is a straightforward verification or validation. As you can see, as we go changing between the different methods, the bottom part changes, right? To suit the process that we're going to execute later. Okay, so this general part, we're not going to fill in yet anything because we want, as I mentioned before, to just define the skeleton, the overall structure, and later assign it to, in this case, the entire product breakdown structure, and then start customizing each one of them. Okay. So we go into the product configuration. Sorry, we go into verification, and here we can see the red cross, and we can just right-click and assign template. And we have now assigned the verification template, okay? You can actually tailor and edit it here from here directly, right? Which is another layer for you to customize prior to, let's say, execution. We go now onto the VMV assurance tab, so where we have all the information. We have just changed the view from validation, which was the by default one, onto verification. And now, as we want to continue editing and preparing for the verification process, we're going to swap the mode onto edit verification action and simply double click on top of it. As you can see, the view has changed a little bit already, right? We have now on top, we have the name, we have the technique, and we have the method, right? But here below, we have all the information available for us to edit once again, okay? The first thing that we do is to select, sorry, let me go back a little bit. Okay. Perfect. So the first thing that we're going to do is in the general section, we're going to select the decomposition level. So at which level are we currently in? In this case, this element is the temperature water, which is the system of interest, right? So we're going to select system of interest, and within the PBS, this is coming directly from the ontology. We're going to select the option accordingly, right? Now what we're doing is basically defining the objective for this particular verification action, okay? The next step is going to be defining each and every one of the activities to perform. Remember that we are still preparing for the verification process that most likely someone else is going to perform later, right? Which is the person who I call the verification or validation agent, right? So right now, you could imagine that we are the verification administrator, as I like to call it, right? The person who is responsible for defining which is going to be the process, right? Or the foundations for the process to be executed later, okay? Once we have the different steps and the activities, we're going to go on to the expected evidence. This is very important. This represents basically what do we want for the process to be successful, right? And if we try to access the obtained evidence, on the other hand, we can see that all the options to modify verify are basically disabled. Okay, so as you can see here on the top, the only ones available are the spaces and the zoom in, right? You cannot edit this one because this one can only be filled in once we have moved on to the performing verification and validation step, right? So in the next part, basically what we are going to do in this case for this verification is going to input the expected numeric result, which is going to be 10, define less or equal between the, let's say it's going to be less or equal than 10 milliseconds because we are testing the response time, and we're going to provide a small tolerance. Now for the properties, I also like to mention that we can suit here additional attributes, so information, priority, so on and so forth, right? We'll see later that you can actually include comments and waivers and deviations. But for the sake of this example, we're going to just add 2 of them. You can customize and you can tailor the name for the verification action in this case. And with that, we would just simply save the information and now move on to the next phase, which is going to be, of course, the performing or execution of the verification. So we're going to realize a little bit which are going to be the different steps. The first thing, of course, which we have done previously, is accessing and connecting to the source of information, which contains either the validatable items or the verifiable items. How are you going to perform verification and validation? Well, within the tool, we have 2 actual steps. Okay, so we try to make automatic as much as we can, as much as possible, the process of verification and validation. How do we do this, right? In the case of the processes or methods like the comparison rule, this is pretty straightforward because the tool you can automatically execute the assessment, and the tool will compare these 2 numbers according to the comparison rule and the tolerance that you have defined. And if the number succeeds or the comparison is positive, then the suggested result is going to be suggested as verified, right? If not, then it's going to be suggested not verified, for instance. But in this case, aside from the automatic assessment, you also have the manual evaluation. So there's always a human responsible, a verification agent involved in this process. As I mentioned before, for the checklist now, for instance, you go by filling all the different questions, right? And you provide information for them. You select yes or no or not applicable accordingly. And then as you go by, you can automatically execute the assessment, and the tool is going to go through the questions and say, okay, the suggestion is not verified, right? Or not validated. But then the validation or verification agent is going to come into play and is going to have available the possibility to change manually if the state of the verification action, if he or she considers that there are arguments for it, let's say. Okay. Great. So we have completed previously the preparation for the verification process, and now on the execution, as you can see, there's going to be information which is straightforward or straight away blocked, right? So as you can see, it is a little bit darker, it is gray. The name, the technique, the method, the decomposition level, and the product breakdown structure are all immediately blocked. The objective, the activity to perform, and the expected evidence can also not be modified. Let's say you can visualize them. This is why they're not, let's say, skewed, but you can access them and try to modify them, and you will not be successful, let's say, because these are information that you need to visualize as the person responsible for the execution, but you're not going to be able to or authorized to modify. Okay. So the information that the verification or validation agent is going to be filling in is, in this case, the obtained evidence for the verification and validation process, as well as in this case, as we're dealing with a checklist method, complete the checklist, and then later at the end of the process, as I mentioned, manually change the status of the entire verification action and provide an argumentation for it. Okay. So as you can see here, this is a brief example on 2 ways where you can actually execute the automatic assessment for the selected or for all the verifiable and validatable items. Okay. Now the comparison that we perform and the way to obtain these automatic results is based upon a process which is also defined within the INCOSE handbook, and it is pretty straightforward. It consists on having a reference, so a set of context information, in this case the technique, the method, which are the resources. This is what we have prepared previously in the prepare for verification phase. Then we have the verifiable item, so this is the source item, the engineering item that we connect to. We have the verification action, okay? And this verification action is going to, let's say, contain both sides, right? The reference and the verifiable item. This verification action is going to have 2 pieces of information. The first one is going to be the expected result. So the value in the first example that we had, it was 10, I believe, 10 milliseconds. So this was the expected result. And then which is the obtained result after the simulation, the testing, and so on and so forth, right? We input both pieces of information, and then with both pieces of information, the tool is going to be able to compare them and provide you with a suggest yes, and this is important because it always suggests or suggested no. The suggestion I reiterated because it is only the engineer in the final stage, who's going to be defining, or let's say specifying the absolute status for the verification action, right? So the tool cannot define a verified or non-verified state by itself automatically. It is always the engineer who's going to be selecting this definitive state. And once he or she, let's say, selects the verified or not verified, the tool is no longer going to be able to, let's say, change this state back. Okay. Great. So as I mentioned, this is going to be the final step of the process. It is as simple as selecting change here and picking the option that you find suitable. Okay. Once you select this option, also to mention, here the agent is going to be reflected. The date where you performed the change is going to be selected, and the new status is going to be updated here. Okay. Another important piece of information is going to be the argumentation, right? So we change the status manually, and what we want to do is always provide some piece of information for the person reviewing it to see, okay, well, they have made this specific change because of this or because of that. Okay. Great. So let's take a look at the next video. In this case, we continue. Remember that we are performing the verification. Let me just, I'm going to expand it for you guys, I think. Oh, no, sorry. Okay. So remember that we are performing the execution of the verification process. And in this case, we have selected the option to fill in the information, not to edit the verification action. If you notice here at the very beginning, okay, so we change the option from addition to filling in. We just double click on top of the item that we want to, let's say, verify. And as you can see now, the view has changed. The verifiable item is going to be the item that we had within the previous view. We can define a specific verification phase, right, for each and every one of the verifiable items. We have here the piece of information, right, corresponding to the preparation phase. So this is not modifiable, as I mentioned before. One important piece of data that we have here is the source of the verification process. So this is the item or the element against which we are performing the verification. We have the objective also, that we have the possibility to visualize and console the activity, the set of steps or activities to perform in the verification process, which is going to be the decomposition level and the, let's say, component within the product breakdown structure that it affects. Okay, the expected evidence, and the piece of information that we will be filling in, which is going to be the obtained evidence, right? As well as the obtained numeric result below. Okay, so one thing that we can do prior to this is to specify who is the person who is going to be responsible for executing this verification process, as well as once we have checked or revised the different steps and which is going to be the consistency of the process, we can define the estimated, let's say, resources allocated for this particular verification process, right? And also fill in any information that we want onto the attributes that we have defined previously. Okay. So now let's imagine that we are the verification agent and we have executed the set of different simulations that we wanted to perform. And we have obtained the final value that we want to take out from it, right? In this case, it's the average from the different measurements of the response time. And we have located it to be 11.14. So we input the value, and the next thing that we're going to do is provide the objective evidence for the, let's say, verification process that we have completed, right? So in this case, we're going to simply just provide some reasoning. And the next thing that we will do is attach, let's say, the simulation file, let's say the Excel file containing the simulation that has provided us with the final value of the, let's say, obtained numeric result. Okay. Great. We have also the option to visualize it or to open it directly from the verification action, which is quite, let's say, comfortable, let's say, for the person also who is revising the whole process. And we can actually include or incorporate videos and images into the, let's say, argumentation and the obtained evidence, right? So in this case, I wanted to input the signature of the responsible. And we're going to simply save. And now we will execute the evaluation, the automatic evaluation. So in this case, we can select the by right-clicking or simply the option to evaluate the selected. And as you will see, it will promptly provide you with the response. In this case, this status is going to be suggested as not verified because, of course, the expected value was 10 milliseconds and we are above the 10 milliseconds mark, right? So we're 11:15. You can see that this status has already been reflected here. And also we have the date for the execution, the last execution of the automatic verification, okay? For the sake of this example, I'm gonna say that, well, even though it is up by 1 millisecond approximately, I'm gonna, let's say, provide a waiver, and I'm gonna define, let's say, a set of information to, let's say, overlook this particular problem or this particular exceed in terms of the response time. And I'm going to just define it as a proper waiver. And I'm going to change manually the state from suggested as not verified onto verified, right? You'll notice that now I have the agent defined, which is something that previously was not, okay? Because the tool was performing the assessment automatically. We end the process by simply providing some argumentation. And we're going to close the verification action. Okay. As you can see, the status has been updated and we have additional information on the phase and the number of different verification actions that we are actually tackling. Okay. Now I have just opened the requirements traceability, let's say requirements verification traceability matrix. And in this matrix, I can add a new source, right? This is important because what we're going to do now is providers select the source itself for the verification process. Okay, and we're going to do so by simply just clicking and providing or creating crosses between two different items. In this case, the verification is going to take place between the system itself, right? Between the product breakdown structure components and the system requirements. Okay, so as you can see here on the left-hand side, what we have are all the different components from our product breakdown structure. But here we have one, two, or many different specifications we could have, right? We could add them as sources, and because we could simply define the source for each particular verification action by, as you can see here, double clicking, you create, or the tool creates automatically a cross in the traceability matrix. And if we open again the verification action, you'll notice now that the source section is filled in, right? It contains the information for the specific requirement that we have, let's say, selected on the traceability matrix. Okay. Great. This can also be performed with several examples, let's say with several sources. So you can have one verification action that applies to several different sources. As you can see here, it has also been updated as soon as we have selected it in the matrix. And if we remove it, of course, it will be removed as well. Great. Now, there's also the possibility to include more than one verification action for a verifiable item, right? We might want to verify different things concerning, in this case, the temperature ward system, okay? So you have also the possibility to, as you can see here, just click on the add action option and define it particularly for the specific element, right? We customize and we tailor just as we have performed in the preparation for verification and then in the execution, okay? Now, as I have included a new verification action, the first one was verified, but the second one is just in process. I have not yet completed it. The automatic status is going to be updated onto ongoing. Okay. You will notice also that as I have included a new verification action into my, let's say, temperature warrior system, it appears also in the in the requirements verification traceability matrix. And here I have also the possibility to change the status of this verification and provide an argumentation specifically, let's say, for the change in status in this case. Okay. So with this, we conclude with the performance of the verification, and we move on to the management of results. So as the person responsible for reviewing all these results, we're going to take a look at within the verification action to the obtained evidence section, mainly. You can see here, which are going to be the resources that the agents have left us, right, to check, the evidences that they have specified. We also have the possibility within the tool to access many different views. In this case, the most powerful one is going to be the dashboard, which is the one that you have right now on screen. And you have here, let's say, the overall summary, different summaries by criteria, and evolution scoreboard, let's say, so on and so forth. Okay, so this is a great way to visualize not only the current status of the verification project, but also the evolution of the verification project and the different aspects in terms of different criteria, right? You can also have at any point in time, if you access the verification action, you have the executions tab and the history tab that shows you which have been the major changes in terms of state that the verification action has suffered. And also within the main view, you might have noticed that you also had the number of total number of verification actions alongside with how many of them are passed, how many of them have been failed, and how many of them are, let's say, not applicable or in progress, let's say, right, ongoing. Great. Another view that we have is the browser itself. This is a more abstract and general view, as it comprises all the different elements within the product breakdown structure and allows you to see for each particular element within the system itself, how is the verification or how is the validation process going, right? So with just one click, you can see here this depiction, right, is the overall status, or all the different status that you have currently regarding the specific component, or in this case, the system of the temperature warrior, okay? And here in the middle, you have all the verifiable items that you have related to this product breakdown system component, right? Here in the bottom as well, if you have children or you have elements, subsystems or components below this particular element, which in this case we do, you can also see which are their corresponding states overall, okay? And here finally on the right hand side, it is a little bit cut, but you can see that you can click on all these different items to see their particular verification actions. Aside from the detail view that we call, we also have the graphical view, which allows you to, in just one view, see which is the current status of the entire system, right, in terms of verification. So here we have the temperature warrior alongside with all the different subsystems within it. Building and maintaining the requirements verification traceability matrix, right, as you can see here, with the corresponding links between the sources and the product breakdown structure components. And finally, we also have the possibility to generate reports, okay? Okay, now we're gonna take a look at a small video, a brief video, on how we can actually, let's say, move along these lines. As we can see here, the first step that we have mentioned before is to simply access the verification action to revise which have been the results of the process itself, okay? So which has been the obtained evidence, which is the obtained numeric result in this case, and which has been the status and the argumentation for this status itself. One important thing to also revise, the deviations, and waivers, the executions, which we were mentioning before, right? So here we can see which has been the version, sorry, let me just go a little bit backwards, which has been the version for the verification action, as well as the corresponding version for the verifiable item, because the item can change in terms of version with regards to also the action that we are performing, okay? And here all the different corresponding states. Perfect. Now for the last one is going to be the history tab. And this history tab, as we have mentioned before, includes all the changes in status between the right, the requirements verification traceability matrix. Here you have another view. Okay. You can see here that we can just simplify the view and include only, visualize only the components within the product breakdown structure. We can modify the status once again, but in this case, we are just revising and reviewing which have been the results, okay? So we can trace them against, in this case, the system requirements. Perfect. The argumentation. Let's skip a little bit ahead. Okay, we can access the different verification actions. Okay. And I will show you the evolution scoreboard. Okay. So as you have seen before, the dashboard includes this evolution scoreboard, and it is a little bit more specific, but in this case, the evolution scoreboard deals with the overall progression in terms of status of the entire project. The overall summary includes which is the current frozen image of the project. Below, we have the breakdown in terms of product breakdown structure, so the levels, right? The system, subsystems, and component levels. And we can filter by the status itself to see at any point in time how many failed verification actions, how many past verification actions, or how many ongoing verification we have, right? On the right-hand side, overall summary by criteria, okay? As you can see, we can hover over them and see how many of each specific type we have. We can select from the criteria the verification phase, for instance. And as we select the criteria, you will notice that below the evolution changes according to the criteria that we have selected in the section above, right? So as we have selected the verification phase, right? We can see here verification phase number 1. Let me just highlight my cursor. Verification phase number 1, number 2, number 3, and number 4. Here below in the evolution, the criteria that we're using to show is the verification phase that we have selected, right? So 01, 02, 03, and 04. Okay, we can change this at any point in time. So in this case, by the technique, I want to see which is the current status for the verification, depending or according to, based upon the technique that we have been using, right? And I can just once again filter the evolution by each specific technique. Okay, method as well. Okay. The final part of this view is going to be the tabular section, in which we contain, or we have all the different items that we have, let's say, involved in the verification process. And finally, this is going to be the browser that I have mentioned before. This is the overall view for the entire system or the product breakdown structure. Here we can see, let's say, specifically the current status for all the items in terms of verification and validation for this specific, let's say, component, subsystem, element within the system, etc. Okay, this is the view to, let's say, visualize everything at any point in time. And also, this view includes, this is something that I did not mention before, this also includes, let's say, any verification item that belongs to a different connection, right? So this is not simply for this particular connection, the product breakdown structure or the requirements, right? If you have a model in another connection and you have verified, and this verification concerns the temperature warrior, and you have selected the product breakdown structure as the temperature warrior, this will also appear here, will be reflected, okay? The last thing that we have done, all I was explaining, is basically showcasing the graphical view. We can double click on top of any of the items, and we will, let's say, access the specific subsystem, in this case, the control subsystem. And we can see that we have two components within the control subsystem, and we can see also the current status in terms of verification for each and every one of them. Okay, great. And I will stop here. I will stop the video because I believe this is the most valuable section. The last part is simply mentioning which is going to be the generation for reports, right? So I leave the floor to you, Cecilia, for mentioning the next webinar, and we can go on to the question sections.
Okay, thank you very much, Jose. We will start with the Q&A in a minute. So if you have questions or comments for Jose, please write them down in the question section. And while you are writing, I will give you some information about our next webinar. It's called Meeting ISO 13485, Requirements on Design and Development Inputs by Applying AI Technology. In this webinar, we have invited Peter Stibelius, one of the authors of the ISO 13485 standard for medical devices. And he will show us what the requirements for design and development inputs are. We will also see how CES Engineering Studio can perform requirements quality analysis, provide an interactive writing assistant, and help you achieve traceability. And the dates for this webinar are the 27th and the 29th of February. Okay, so over to Q&A. Is it possible to filter which objects we would like to verify or validate?
Thank you for the question. Yes, indeed, you can, if you have a specification, right? I believe you were mentioning in terms of if you have, for instance, a document and you want to import requirements, but you also have text and descriptions which you might not want to verify. I believe this is what you mean. If not, please correct me. You can actually filter in the project configuration. This is something that I did not show, but you can actually go into the properties and select specifically which type of element do you want to involved in the verification process. So those elements which are not involved will be just simply highlighted as gray and will not be, let's say, included in the set of verification items or verifiable items, right? So you will not be evaluating them and wasting time on their processes. Okay, so hopefully this answers your question.
Okay. Another question, and what if the verification is performed by a third party who does not have access to the tool?
That is a great question. Usually the main process goes as we have showcased, right? So both the verification administrator and the verification agent, the two people involved in the preparation and the execution, plus the results management process. We based it upon the idea that everyone has the tool to access it and to perform these processes that I showcased, but you also have the possibility to generate some sort of templates, right? So this process can be exported onto Word. You can actually simply perform the preparation, and then generate these what we call verification forms. And this is basically a MS Word document where you can take it, send it to the third party that has to that is responsible for the verification or validation process. They can fill in because it is like some sort of a form for you to have different, let's say, editable spaces, and then you provide the information, and as the format it is predefined, you can actually re-import it back onto the tool and just simply dump the results into the SES Engineering Studio, right? So you would have all the information. It would be as if you had completed the process within the tool, but not having to actually access it, right? So I believe this would be a potential solution for the use case you provide, which we of course have tried to consider as well. Okay.
Okay, thank you. So let's finish here. Thank you everybody for attending. If you have any additional questions or want more information about our tools, don't hesitate to contact us by email to contact@reuscompany.com or directly to Jose. You can also find information on our website, reuscompany.com. So thank you very much and goodbye.
Thank you, everyone. Goodbye. Take care.